redox reactions and equilibrium. Why should we study this topic? Because all living organisms are controlled only by electrical signals. It is the first reason. And the second one, electrical and electronic equipment is very used in different types of medical and biochemical researchers and in medical practice. You remember that oxidation is loss of electrons and reduction is gain of electrons. But these half reactions go only together. They couldn't take place separately. It's why usually we summarize them and call redox reactions. They may go in solution and electrons transported from one particle to the second one, or they could be separated and take place on different electrodes. Nernst equation is used to calculate potential of the electrode. In this equation, R is gas constant, T is temperature, F Faraday constant, and number of electrons which take part in half reaction. Instead of activity, we usually take concentration. These forms of Nernst equation are the most useful. But pay your attention that instead of plus you may see minus somewhere, and it depends where the concentration of oxidized or reduced form is written. Or one more point. You see, in Nernst equation R and F are constants, and if process goes at standard condition at room temperature 25 degrees, it is common to use product of these constants 0.059 and log instead of Ln. If concentrations of reduced and oxidized forms are equal to 1, log of 1 is 0 and E will be equal to E0, to standard electrode potential. This potential is measured at standard condition and unit temperature. These standard electrode potentials are given in tables, and looking at this table you could compare oxidizing or reducing properties of redox pairs. To measure electrode potentials, different types of electrodes are used. These are redox electrodes, first and second type electrodes. Redox electrode or zero-class electrode. It is non-active metal, usually it is platinum, which is placed in solution containing two forms of electroactive compound. For example, platinum, which is placed in solution containing Fe3+ and Fe2+. And Nernst equation to calculate potential of this electrode is given. Sometimes processes are more complex and hydrogen ions or OH ions take part in these processes. In this case, Nernst equation for calculation of this potential is a bit more complex too. You could see this at the second example. First type electrodes. These electrodes are metals which are placed in these metal salt solutions. For example, Cu in Cu soluble salt. Nernst equations to calculate these potentials are given, and here you see two examples, copper electrode and zinc electrode. You see, N is equal to 2 because only 2 electrodes take part in half reaction. You could see example of problem solution in which you use Nernst equation to calculate potential of copper electrode, which is placed in 0.1 molar copper sulfate solution. Standard hydrogen electrode, it is the main reference electrode. It consists of platinum, which is placed in acidic solution, which concentration of hydrogen ions 1 mole per liter, and hydrogen gas is bubbled through this solution. Pressure of hydrogen is equal 1 atmosphere. Potential of this electrode is taken as 0 at any temperature. Let's compare hydrogen electrode and standard hydrogen electrode. At the left you could see standard hydrogen electrode, and it is understandable that pressure of hydrogen gas should be 1 atmosphere and concentration of hydrogen ions 1 mole per liter. In this case, potential of hydrogen electrode is equal to 0. For hydrogen electrode, concentration of hydrogen ions may be different, and these two equations could be used to calculate hydrogen electrode potential, which depends on hydrogen ions concentration. Second class electrodes. These electrodes consist of non-active metal, usually it is silver or mercury, which is covered by its insoluble salt and placed in solution of soluble salt with same or common ion. These electrodes are often used as reference electrodes instead of hydrogen, which is not very comfortable to use. The most famous of second type electrodes is silver chloride electrode. It consists of silver covered by AgCl, which is insoluble silver salt, and this system is placed in KCl solution, soluble salt with common anion. And equation for silver chloride electrodes potential calculation is given. Ion selective electrodes. This special type of electrodes, potential of these electrodes depends on one ion concentration. For example, glass electrode, it is ion selective electrodes in respect to hydrogen ions. Its potential depends only on hydrogen ions concentration. You could see this. And this electrode is very useful in biology, in medicine, to measure pH of biological liquids, because its potential depends only on hydrogen ions. Other ions don't affect on this potential. You could see example of some other ion selective electrodes. Their potential depends on sodium or calcium or cyanide and other ions concentration. Ion selective electrodes are very useful in medicine and biology. You see examples of some common famous biosensors. To measure potential, we should have electrochemical cell, which consists of two electrodes. Galvanic cell. There are two electrodes on one of them reduction process take place and on other oxidation process. Let's talk about Daniell cell, which is one of the famous galvanic cells. This Daniell cell consists of copper electrode and zinc electrode, and zinc atoms get oxidized in this Daniell cell and form zinc ions, whereas Cu ions get reduced and form Cu atoms. We can calculate electromotive force of this process, EMF, as a difference between potential of cathode and potential of anode. If EMF is positive, process is spontaneous, and vice versa. If EMF is negative, process is non-spontaneous. One more type of cells is concentration cell. You could see example where concentration cell consists of two silver electrodes which are placed in solutions with different concentration of AgNO3. It's why electrochemical process takes place in this cell. For all potentiometric measurements, there are two electrodes which are necessary. These are reference electrode and indicator electrode. For medical researchers, it's very useful silver chloride electrode as a reference electrode and glass electrode as a work electrode to measure pH or hydrogen ions concentrations. One more example of potentiometry in biomedical researchers. This picture is taken from physiology, and you see that potential of nerve cell is measured by platinum electrode, which is work electrode, and silver chloride electrode, which is reference electrode. This type of measurement is very important to explain nerve system work. Yeah? You know that our brain takes signals from our tissues and cells only because of different types of potentials. You will study it on physiology. Biochemical reactions, you see some examples. All reactions have their own standard potentials, you see. And which reaction will take place, which will be the first, it depends on this standard potential. And all processes in our body, for example, electron transport chain, their work depends on these standard potentials. Thank you.